Fine afternoon, everybody. In the class of mechatronics, as per the today's class, we would like to proceed regarding the directional control valves in the today's class. As per the previous classes, we have been considered, we have been learnt about both the hydraulic systems, hydraulic actuators, and the pneumatic actuators, which tends to work with respect to different parameters in the real industrial fields. So here, at that particular time, we have got a detailed discussion that the pneumatic supply that is being provided by the compressor at a prescribed pressure indeed to work the actuator that is in the forward stroke towards the forward stroke or else the return stroke, that is contraction stroke. And even if that particular system has been arranged in a vertical mode of action, then it will be moving on towards the extension that is altitude wise, that is height related, and even contraction. We will be calling as this moving on a material from one elevation or ground floor to the first floor and then first floor to the second floor, vice versa, and simultaneously towards the from descending order, that is the second floor to the first floor and then first floor to the ground floor back again. So for this, the changing of these motions towards the forward and reverse leads to a typical task such that the pressurized air when it has been got into the leakage, then it will naturally gone to an explosion in condition, whereas the compressed air or gaseous has been considered, that is the explosions may be taken place. So without commencing that particular activity, the directional changes will be taking place by these valves, that is directional control valves. And in the case of these hydraulic systems also, or hydraulic actuators also, that is we all aware of these hydraulic systems, that these will be working with the pressurized fluids. So here, as this pressurized fluids also plays a major important role, that it itself acts as a self lubricant, whereas in the pneumatic already we have been discussed that FRL unit has to be utilized. So here, indeed, to guide the pressurized fluids, the directional control valves tends to act that the controllers plays a major important role to move the actuators towards the forward stroke or else towards the left or return stroke. So it acts as a major conspiracy. So the on and off conditions is completely necessary for both the strategies of the systems, that is either in the open loop or else in the closed loop. We all aware of these differences between this open loop and the closed loop. Open loop in the sense there will not be any feedback directly based upon the given input, the output will be getting generated. Simultaneously, in the case of this closed loop control system, you will be having the feedback and it will be comparing with respect to the reference signal or reference, that is an input given to the system, and corresponding output need to be generated. And based upon that, the justification will be getting progressed with respect to the controlled production or manufacturing, whatsoever it may be in the industrial fields. So here, indeed to commence these actions. So what are the type of actions? So here in the case of these hydraulic systems, the pressurized fluids need to be directed in such a way that what is the task that to be performed by the actuator, whether it has to tends to move towards the forward stroke or else to the reverse stroke. So after completing the forward stroke, and what are the changes that need to be taken or fluid direction need to be changed. So for that, these directional control valves plays a major important role. Hence, what are the common type of systems or these fluid flow directional in the case of actuation related to these actuators? There are mechanical modes, electrical modes, and Even the pneumatic also can be considered for the driving factors. For the driving factors, so there are four modes of operation in the case of this DCVS generations. First one it is mechanical mode, next one it is an electrical mode, and the another one more name for this electrical system it is solenoid system, and third one it is an hydraulic system of operation and a pneumatic system of operation. That is nothing but even this directional control valves also can be controlled with respect to this hydraulic and pneumatic strategy. And other than that, mechanical and solenoid control system, solenoid in the sense the electrical control systems will be utilized. And considering the activation modes or directional aspects, there will be the common types of valves here as it has been considered. First one it is a spool type of valve, second it is rotary spool valve, third one it is poppet valve, and fourth one it is unidirectional valve. So here we'll be having a detailed look regarding this general types of directional control valves, and furtherly we will be discussing the special kinds of valves. Considering this spool type of valves, see here these will move horizontally within the valve body to the controlled flow. So here it clearly specifies that here in the port 1, port 2, port 3. So there are three different ports. So first one it is air that will be supplied to the spool. So here just have a look here. That's when the port 1 is in open condition, simultaneously this port 3 will be in closed condition. That is nothing but the spool will be moving with respect to the frame of this cylinder surface, right? So here we are discussing that when the air, in the case of pneumatic operation mode, compressed air will be getting supplied. So when it will be getting supplied, when the spool valve is completely extended towards the right side, then it will be getting supplied. So this port 1 will continuously drives here, and in the second condition, at that first similar spool type of valve, when this port 1 is in open in condition, then it will be supplying only to the port 2. Simultaneously port 3 will be closed. So nothing but if it has been in open condition, directly it will be released to the atmosphere. So it will be directing that entry will be here and exit port, and this hose pipe which is connected here will be connected to the actuator. So here port 1 will be connected to the compressor. So compressor which compresses the air, that will be supplied to this port, and from this port it is from the port 2 onwards it will be directing to the particular actuator which has to be operated. Simultaneously, when this has been moved towards the left side direction, this port 1 will be open in condition, and retraction stroke in the case of, and hence it leads to the forward stroke, and retraction stroke. Retraction stroke leads to the port 2 which is pressurized air enters into the cylinder, then this port 3 will be in open condition, so vent condition. So here there will not be any back pressure. So when this spool valve has been moved towards the left side direction, port 1 will be closed by this spool end, that is right end, and this left will be in open in condition, and here which has been pressurized air has been entered into the cylinder will be left back, and this will be released to the atmosphere, and hence here vent to the atmosphere has been given, and towards its extreme left side direction supply from the compressor will be getting stopped, and already entered pressurized air will be retracted back, and hence that will be considering as an return stroke, and the returned back air, pressurized air will be left from this vent to the atmosphere directly. And this is the condition of second one. That is port 1 will be in closed condition when the spool has been completely in the extreme left condition. So already entered fluid will not be tends to move towards the port 1, and hence the gas is always tends to move towards the open space. That is nothing but high volume, and directly it will be attached with respect to the atmosphere, and hence will be releasing towards the atmospheric, leads to the common conditions, that is n common n conditions. Hence we are having another condition type of valves, not only in the sliding motion, simultaneously there will be rotary kinds of spool valves also. So rotations in the case of this 360 degrees, when it rotates it will be opening and closing the ports simultaneously, as in the case of linear movement we have been seen. So moving on to the puppet valves. So coming to the point of puppet valves. So here external pressure need to be initiated for its actuation. For its actuation. So initially, just we'll be having a look over here. There will be an tension containing springs which will be attached with respect to the bob, and this bob is being maintained with respect to this particular button or externally supported conditions. When this particular puppet wall has been pressed by external force application, then these will this force will tends to compress the spring by the extension of this particular bob, and hence the condition will be here. And the pressure supply of this port will be continuously supplied, but when this is in the spring is in extended position, then at that particular time there will not be any pressure application here at the external application of pressure. At that particular time it tends to move towards the against condition. When the pressure has been applied, nothing but pressed conditions. So this is the difference, pressed condition, and hence the entered pressure will be changed in the form of the tension that has been compressed with respect to the spring, and hence this will be an stopper and open in condition, and hence the movement of this gaseous medium, that is nothing but compressed air, or else the fluid effects, that will be moved to the second port, and entry is the port 1, pressurized either fluid or this gaseous medium will be entering to the port 1 by the port 1, and when it is in pressed or external pressure applied conditions, this will be moved or leaked towards the second condition. The supply will be in second condition. So here, not only in the single port, multi-level ports also can be maintained. Simultaneously, port 3 can be maintained over here, but high pressurized condition need to be utilized. So that is the condition of this puppet valves, where we will be utilizing. Generally, we will be seeing our normal water taps also. So when you have been pressed that particular tap, the water will be letting out. So there will be a continuous supply from the tank onwards. But whenever the external pressure has been applied, these are the conditions that are being taking place, or directional control valve, one of the directional control valve, nothing but puppet valve, will direct the fluid to enter from port 1, which is obstructing, will be getting released at the obstacle point, and next will be moving to the point number 2, that is port number 2. This is the condition. So normally it will be in closed condition. So this is the strategy. Normally it will be in closed condition. When the pressure has been applied, pressed, nothing but pressure applied, pressed condition, then only the outlet will be getting opened. So in this, walls, balls, discs, and cones, whatever it may be, the shapes here in the stoppers, as in stoppers, can be utilized, right? When this push button is depressed, the ball is pushed out of its seat and flow occurs as a result of port 1 being connected to the port 2. So connected from port 1 to port 2, in the sense that there will be a passage of compressed air, or else the compressed fluid that is being driven indeed to move from port 1 to port 2. All right, next one. Considering in the case of this unidirectional valves, free flow can only occur in one directional control valves. So only unidirectional here, name itself specifying that there will not be any movement occurring in the other side direction. So considering two different cases here, with the tension containing or absorbing by an external pressure, and second one, it is the there is nothing but check valve and check valve. So check valve strategy, and hence it is opposing pressure with respect to the tension containing in the spring. So here, when the flow, when it is possible in direction, so when the fluid with an high pressure enters here, that pressure will get tends to move this particular obstacle of valve in the form of compressing factor, or nothing but tension that is being creating by compressing this particular spring. All right. So whatever the pressure is being entered, or force that is being entering with an offense, that is either it may be fluid medium or nothing but liquid medium, or else the gaseous medium. So gaseous medium in the sense this pneumatic condition, and vice versa, it is an liquid medium in the sense this is an hydraulic in condition. So these will be entering, and that causes the tension in the spring, which tends to move this particular valve upon compression, and will be fluid will be entering here, and simultaneously that will be moving towards the left side, towards the right side port, and hence there is no any possibility of a flow here. So if there is any black flow occurrence, simultaneously, if the pressure has been cut off here, this tension creating in the spring will be getting released, and this bubble will be blocking the valve entering. So at that particular time, already causing the tension in without entering this already entered fluid towards the backside direction. When there is any another force that is applied in counter direction, there will not be any movement causing here. There is no any leakage appearance here, and hence there is no any back flow of movement. Simultaneously, in the case of this check valve also, nominally this check valve will be utilizing the in the different motors in our domestical purpose also to pump the water from the pipes without moving on towards the backside movement. So it will be carrying the water at an high pressurized condition, in a high pressurized conditions to the overhead tank. All right. So here just we'll be having a look. There will be a similar flow. When the pressure is being entered here, this ball valve will be getting in extension condition. The fluid will be flowing in a forward direction. Simultaneously, if there is any negative flow, then vice versa. Here, this will be getting closed in condition, will not be entering into the backward movement. Obviously, there will not be any backward movement condition that is being taking place. Coming to the solenoid conditions. So solenoid here clearly specifying that which are electrically related, which are electrical related. So your solenoid will be having an electrical in the sense the current EMF has to be produced or supplied indeed to commence the activity. All right. So solenoids. The solenoid is in coil wound into a tightly packed helix shape. So already helix shape it has been mentioned over here. All right. So in physics, the term in the case of this physics, the term that is solenoid, it refers to a long, thin a loop of wire and wrapped. Wrapped in the sense there is a metallic core which will be wounded again. So wrapped around a metallic core, right? So it produces a magnetic field when an electrical current is applied. When the EMF has been applied, it produces the electrical field strength, and the voltage will be getting. So this generated magnetic field will impart the additional EMF, or generated in the form of voltage, will be utilized furtherly for the commencement of activity, or that impulse, that EMF generated will be sensed, that the extension of this particular actuator has been commenced. Nothing but extension has been commenced, and vice versa, the contraction has been commenced in the similar strategy. And coming to the valve symbolic representations. So how these valves has been represented. So how the port insertion will be taking place, and simultaneously the contraction will be taking place in conditions. So here the walls, these walls consist of the square type of box, and here there will be an ports and positions. So each and every square box represents the a position, and each and every condition here specifies let in and let out switches or ways, and these dots or notches represents the ways or number of ways that are having. So here, considering this square box as a position, so each and every square box is considered as a position, and simultaneously each and every passage is consists of an one directional constraint. There is an ports, we'll be calling as an ports. So here there are two specific names, ports and positions. So here for each and every condition, so one square box, it is in position, one position, and hence this is an port 1, port 2. So two ports entering, leaving simultaneously. This is in halting in condition. Simultaneously here it is one position, but there are four ports. So two input ports in the case of this is C, two output ports. So entering here in the downward direction. So here the position, the same position, the number of ports, inlet ports 2, outlet ports another 2. So when you have been considered in this as a common strategy, you'll be considering this as an, if we are having these four constraining square boxes commenced within two different positions, then we'll be calling as an 4 by 2. So 4 in the sense position of ports specifies the numerator strategy, denominator will be specifying with respect to how many number of square boxes that we are having, that is n number of positions. So that way we'll be calling as 2 by 2 valve, 1 by 2 valve. So here it specifies this 2 by 1 valve. So here we are having two ports, port number 1 as an input, port number 2 as an output. So two ports and position is only one. And here also B diagram also specifies the same strategy, but here there is an arrow mark specifies the flow that is being connected from port 1 to port 2, and here these notches or halting stoppers specifies that there is no any connection, there is no any forward movement, and vice versa, there is no any return movement. So hence there is an ideal in operation, hence there is no any connection. But here there is a forward connection. Arrow mark specifies the forward connection which connects this port 1 to the port 2. Here also this also contains two ports, and square box is one square box, hence position is 1. So two ports, numerator is 2 and denominator is 1 position, it is 1, and hence we'll be calling this B diagram as an 2 by 1 way controlled valve. Simultaneously coming to the point number C, diagram number C. So this diagram C is consisting of one port, two ports, third port and fourth port. So two input ports, two output ports. Hence we are considering four, having four different ports. So hence this diagram number C is called four ports, and denominator, coming to the denominator, we are having only one position. So there is an individual square box, and hence it is considered as only one, and hence four ports, single position, 4 by 1 way controlled valve, right? That will be calling, right? So if this four ports containing box is commonly connected here, then we'll be calling 4 by 2, because two positions will be existing. If it is in 3, there will be 3 positions, and continuously it will be extending. This is the condition. So there are four different ports and two different square boxes which are interconnected, and this is called four ports and two position container, 4 by 2 way control valve. Simultaneously if there is any another one more square box which has been attached to this, simultaneously four ports is existing for three positions, so 4 by 3 way control valve, and hence these are the valve symbolic representations. And how the valve is being actuated, it clearly specifying, right? So This is called two ports and so one port, and hence one port. Positions is two. So here 2 by 2-way controlled valve. So upon activation, how the activation need to be considered? So activation in the sense external power supply need to be generated, and we already discussed that in order to activate these directional control valves also, four different modes of steps are having. First one it is mechanical mode, next one it is electrical mode, and third one it is pneumatic mode, and fourth one it is hydraulic mode. So we'll be having a detailed look in the mechanical mode of actuation. This is a push button system, that is nothing but externally applying the force or pressure by pressing. Next one by plunger. So when the plunger has been retracted, coming to the point of simultaneously as per the plunger we are having this lever. So when the lever has been operated with respect to the external supply, then automatically this will actuate in the forward movement of this DCV or return movement of this DCV. Simultaneously the rotor, when it has been moved in a rotated in clockwise direction, it will be moving in connected towards the forward direction. There is nothing but first position will be connected, and when the return stroke it will be connected towards the second port. In such a way this roller operating. So these are all, even the pedal system, this pedal system, and even the spring system also extension forces. So these and all are related to the mechanical modes of operations. And coming to the point of this pneumatic condition, so pneumatic in the sense indeed to actuate these positions also, position number one and simultaneously the position number two, this pressurized air will be utilizing pneumatic. The symbolic representation is this one triangular symbol which is supplying. So that is internally there will be in dome condition, there is no any hatchings. If internal hatchings is also in fully dark conditions, then it will be the symbolic representation will represent the hydraulic way of strategy. So hence hydraulic also will be utilized. And coming to the next mode, that is in solenoid mode. Solenoid mode, that is nothing but the electrical supply. So in this electrical supply the symbolic representation is this one. So electrical power supply will be initiated for the position commencement. So position 1 implies the forward stroke, position 2 implies the return stroke. These are the valve actuation symbols which energizes or activates the different kinds of positions in the operational module. And here we'll be having a detailed look in the case of the solenoid operated spool valve when it has been connected with respect to the our directional control valve. So hence the directional control valve which displayed here will be having a look. So first one it is having one square and second square which is connected interlinkedly. So we are having position, square represents the position, so two positions we are having. So denominator value is 2 positions. Coming to the numerator strategy, how many number of ports that we are having? So one port, two ports, and three ports. So there is any no any fourth port here. Here also there is no port, and hence three ports are existing. Hence we will be nomenclating this as an 3 by 2 way control valve. So in which way it is being controlled? Solenoid control. First one it is solenoid operated. So 3 by 2 way solenoid operated spring return. So here mechanical, the spring return in forward stroke when this valve need to be operated, this solenoid will be highlighting at that particular time, this force will be obtained. Next, simultaneously, this tension will be creating in the spring. When it retracts back, it releases the already existing stress or this contracted force or pressure. And simultaneously, this second position will be continuously applied. Second position. So second position in the sense this is the position nominally entering first port, second port, third port. All right, so that is returnly connected, first one is interconnected. So nominally it will be connected, So return travel and return connection, then solenoid will be applied, this position will be coming to the highlight and this to here, so as it represents and return port. All right, so here conditions that are being applied. First one connectivity and so this is an output pressure supply. So pressure supply, first one initial condition. So at that particular time it will be while entering the pressure, the output is being existing here. So hence it is in closed condition, there is no any movement here, and here there is no any movement over here. And in the case of this second strategy, the output pressure which is being connected as an input will be no any supply. So as we have been specified here, first port, third one it is an return port, and second one is an output port. So here first one is pressure port, second one is an output port, and next third one it is an exhaust port. So when pressure is being entering this side, so there is a stopper here will not be entering, and there's an cylinder surface will be enclosing, and here there is a stopper and will be extending towards the output. So this output leads to the common generation. In the case of this spool valve, internal structure of this particular DCV we are being shown in the case of the spool valve here. Simultaneously, when this particular solenoid has been highlighted, second condition. So second condition, this output will be letting back the towards the exhaust port. This is the condition in the case of this spool valve operation DCV. All right. So this is the 3 by 2 way controlled valve. And in the hydraulic actuators, simultaneously in the case of this hydraulic actuators also, the same valves will be utilized, but only one thing it is here, in the pressurized air, that is pneumatic, when you have been utilized, that will be directly released at the return stroke from the output to the exhaust directly in the pneumatic conditions. But this draining has to be existed in the case of this hydraulic source. If this draining will be drived back or exhausted back to the oil reservoir, and that oil reservoir again will be pumped to the first input condition. So pressure supply, so pressure supply in the sense pressurized fluid supply in the case of hydraulic. So in the case of pneumatic, pressurized air, right? Such a condition. So here also the same description will be highlighting in the case of this hydraulic system. All right. Working of an hydraulic actuator will be seeing in the next class. Thank you.